Assalamu alaikum guys, welcome back. Okay, so now we are going to do the reactions of the remainder reactions of the remaining elements with chlorine, and then we are going to do the reaction of the the chlorides of period 3 with water. Okay, which of the chlorides dissolve and which of them react with water. Let's get started now. Okay, silicon when reacts with chlorine will form SiCl4, silicon tetrachloride, and this silicon tetrachloride is not actually a giant covalent structure. That's the interesting fact over here. Silicon tetrachloride actually is a simple covalent structure. Okay, it has a simple covalent structure. It has weak van der Waals forces which are responsible for its melting point. Therefore, it is a colorless fuming liquid. It is simple molecular and has a low melting point. Okay, SiCl4, this is a colorless fuming liquid and is very important for your exams, for your CIs, for your past papers. Okay, so must learn them. Okay, silicon on the other hand is actually a giant covalent structure. Okay, then come to phosphorus. Phosphorus when reacts with chlorine forms PCl3, phosphorus trichloride. Okay, phosphorus, and by the way, the examiner can actually ask you to suggest the shape of SiCl4. What's the shape of SiCl4? Silicon is tetravalent, right? Tetravalent means it has 4 bonds. 1, 2, 3, 4. 4 bonds and no lone pairs mean that its shape is gonna be how much? Bond angle is gonna be 109.5 degrees, and it's gonna be a tetrahedral structure. Okay, so silicon tetrachloride is tetrahedral in shape. Now coming to PCl3, phosphorus trichloride or phosphorus chloride. Now phosphorus trichloride, it actually contains it is a trigonal pyramidal structure. Its bond angle is 107 because phosphorus and its shape is similar to that of ammonia, because phosphorus is also in group 5, and this is the sort of reaction that you must include, and its physical state is also important. It is also a fuming volatile liquid. Basically it rapidly converts into a gas. Okay, so it is still a liquid, it is fuming, and so if you get PCl3 produced in a reaction, you will definitely get fumes as well as an observation. Okay, so if the examiner asks you to write down an observation, so fumes are observed. Okay, white fumes. Then coming to phosphorus reacting with excess chlorine. When phosphorus reacts with excess chlorine, it forms PCl5, and PCl5 is actually a white solid. This is a white colored solid, white solid. The reason why it is a white solid is because of its intermolecular forces. Okay, PCl3 was a liquid whereas PCl5 is a solid. Both of them are actually somewhat non-polar. They do not contain hydrogen bonds, nor do they contain permanent dipole interactions, but it's actually the van der Waals forces that are more dominant in PCl5 as compared to PCl3. So since due to the greater MR and a greater number of polarizable electrons, so more energy would be needed to overcome the intermolecular forces in PCl5. Therefore it is a solid and has a higher melting point as compared to PCl3. Okay, and it is also a simple covalent structure. PCl3 is a fuming liquid, simple covalent. PCl5 is a solid, and it is also a simple covalent. Okay, and this completes the reactions of elements with chlorine. Now let's go on to reaction of the chlorides, which have been formed by reacting with chlorine with water. Okay, reaction of the chlorides with water, chlorides of period 3 with water. The first chloride that we studied was sodium chloride. It's the common table salt. When you add a tablespoon of the table salt into water, do you observe something? Well, does any reaction occur? Well, actually no reaction occurs. It simply dissolves. Okay, it simply dissolves when you add sodium chloride to excess water. Excess water is represented as AQ. Okay, this is AQ aqueous. Then you'll get the sodium chloride. Since it is ionic, when it is added to water, it dissociates into its ions. It forms positive cations of sodium and negative anions of chloride. Okay, and both of them are aqueous. And why does anything dissolve in water? Okay, there are actually 2 major reasons for anything to dissolve in water. The first is either it should be able to form either it should be capable of forming hydrogen bonds with water. Remember hydrogen bonds? We did hydrogen bonds. So anything would be soluble in water as long as it can form hydrogen bonds with water. But sodium chloride does not have any hydrogen in there. nor does it have nitrogen, oxygen or fluorine in there, nor is it covalent, it cannot form hydrogen bonds with water, then why is it still soluble in water? The answer to that is right over here. There is a second type of interaction called the ion dipole interaction, ION, ion dipole interaction, dipole interaction. Ion dipole interaction is basically also a form of bonding or a form of interaction. It's actually a dative bond, but we do not represent it in the form of a dative bond. Okay, it is actually a dative bond, but ion dipole interaction is what is also responsible for the dissolution of a substance in aqueous solution or water. Now, how are ion dipoles formed? Well, basically, if you look at this example over here, I have drawn the structure of magnesium, right over here, magnesium. You can place sodium instead as well, it's up to you. Around each magnesium atom or ion, the water molecule organizes itself. Okay, it organizes itself. Water molecule, if you guys remember the previous lecture on covalent bonding and intermolecular forces and polarity and non-polar compounds, I told you that water actually has a slightly negative charge on oxygen and a slightly positive charge on hydrogen, a partial positive and a partial negative charge on oxygen, partial negative on oxygen, partial positive on hydrogen. This partial negative charge on oxygen, it is a negative charge, right? Although it's partial, it's a slight negative, but it is still negative, and this negativity would cause the water molecules to get attracted to the magnesium ions, which are positively charged ions. And this interaction between the water molecules and the magnesium ions, or the water molecules and the sodium ions, actually form ion dipole interactions, and anything that is able to form ion dipole interactions with water is capable of dissolving in water. Okay, so that's why sodium chloride is gonna dissolve in water, and magnesium chloride will also dissolve in water. Okay, first of all, let's talk about sodium chloride. If you are asked to describe what will happen when sodium chloride is added to water and magnesium chloride is added to water, the key term that you must include is dissolve. Okay, this is the term for which the marks are reserved in their marking scheme, that both of these chlorides will actually dissolve in an excess of water into which they are added. Okay, and they'll dissociate into their ions, so they'll dissolve, they won't react with water to form some other product. Okay, they'll just form ion dipole interactions, and that's it. The pH of both the solutions is very, very important. pH of sodium chloride when it dissolves in water is 7. It's exactly 7. Okay, it's neutral. But in case of magnesium chloride, the pH is 6.5. It's 6.5. So is it acidic or alkaline? It's slightly acidic. Magnesium chloride has a slightly acidic pH when it dissolves in water. Now, why? What's the reason for this slightly acidic pH? Well, anything that decreases the pH is an acid. An acid actually produces protons or H positive ions in aqueous solution, right? It's actually the aqueous solutions which are made, the H positive ions which are made, that cause the pH to fall. Remember, I told you that magnesium chloride is an ionic compound with some covalent character, right? In the previous lecture, so it has some covalent character. So, and covalent character actually, just this is a rule of thumb, that covalent character shifts more towards the acidic side. Okay, any compound that's going to be covalent will more likely to be acidic, HCl, H2SO4, well, yeah, somewhat, and HCl. So yeah, they are covalent. So magnesium chloride has partially covalent or slightly covalent character, due to which its pH is slightly acidic. But the main reason is not this. It's gonna be explained over here, and that reason actually for magnesium chloride you don't need to even know. Okay, it's not a part of the syllabus for magnesium chloride. If you are asked to describe what will happen when magnesium chloride is added to water, it will dissolve simple, okay, in the Cambridge CAIE syllabus. But the real reason is not this. Let's look at the real reason. Aluminum chloride over here, when it dissolves in water, what happens? Aluminum chloride, is it ionic or covalent? That's the first question you must ask yourself. It is purely covalent. Okay, aluminum chloride is purely covalent. And since it is covalent, it will not dissolve in water, rather it will react with water. Okay, it will react with water, or it will hydrolyze in water. This is the key term that you must include in your answer now. What will you observe? You will observe aluminum reacting with water, or you will observe aluminum hydrolyzing in water. This AlCl3, oh sorry, not aluminum, the AlCl3 hydrolyzing in water. Okay, now this AlCl3 will react with water molecules, 6 water molecules, and the 6 water molecules will form ion dipole interactions with aluminum like this. Okay, the partial negative oxygen will face towards the aluminum ion. Okay, because of its opposite polarity, opposite charge, and due to this an attraction develops between them. Now this entire ion which is formed over here, this entire thing actually has a charge of 3 positive. Why 3 positive? Because water molecule is neutral and aluminum has a charge of +3, right? Aluminum, it gets a charge of +3, right? Ions, the ions which are formed by aluminum have a charge of +3. Now since aluminum has a charge of +3 and water is neutral, so the overall charge on this entire complex ion is +3. This ion is now called a complex ion, okay? But you don't need to know the name of complex ion because it's going to be done in a lot more detail in your A2 chemistry and transition metals. Now, this aluminum, this ion which is formed, now what's the significance? This ion was also formed in case of sodium, and that ion was also formed in case of magnesium. But the pH of aluminum chloride is 3. It is the most acidic, whereas the pH of sodium chloride and magnesium chloride were 6, 7 and 6.5. They were more alkaline as compared to that pH which is acidic, which is 3. Why? Now the why needs to be answered for aluminum chloride. Yes, the examiner will ask you that why the pH is 3, explain your answer. So now let's explain the answer. Guys, remember one thing, this aluminum over here, this aluminum, it actually, if you look at it, period 3, as you go across the period, remember in the group trends, I told you that the atomic radius, it shrinks as you go across the period, or the ionic radius for the positive ions also shrinks as we go across the period. Aluminum has the smallest radius as compared to magnesium and sodium, whereas the charge on aluminum is the greatest, it's 3 positive, whereas the charges on magnesium and sodium are lesser than aluminum. So can I say that the charge density of aluminum is the greatest? Right? Charge density was the mass, sorry, the charge per unit volume. Charge is the greatest and volume is the least. So charge per unit volume ratio is going to be the greatest for aluminum. So I can say that the charge density of aluminum is very high, or it is higher than sodium and magnesium. Charge density of aluminum ion is high. Now if the charge density of aluminum is high, what's the significance of that? Now let me tell you the significance behind this. Basically, if the charge density is high, then the aluminum's polarizing power is also going to be high. Polarizing power is also high. Why is the polarizing, okay, what is polarizing power, by the way? Polarizing power actually refers to the ability of this aluminum to attract the electron density around it. Okay, basically the electron density of water molecules which are around the aluminum over here, this aluminum, due to its high charge density, of course, see, it is positive and it is very compact, so of course it will try to attract as many negative ions as possible, right? So it will try to attract the electron density of these water molecules towards itself. This ability to attract or distort or the electron density of the neighboring ions or neighboring species or neighboring atoms is called the polarizing power. Now, if the polarizing power is high, it can polarize a water molecule. Polarize means that one of these molecules, I'll just give you an example of just one water molecule. This bond that each oxygen and hydrogen have in between them, this bond is made up of electrons, right? What this aluminum does is it actually causes this bond to break. How? Well, the bonded electrons, they'll both be attracted towards the oxygen due to the presence of aluminum over there. The aluminum will cause this bond to polarize, or it will cause it to break down. And as soon as this bond is broken down, what happens? An H positive ion is released, whereas the OH negative ion, it remains attracted to the nucleus, to the aluminum basically, and gains a negative charge. I'll repeat this point. The water molecule, initially there was a water molecule over here. Due to the high polarizing power of aluminum, one of the OH bonds breaks, okay, and both the electrons of the water molecule are transferred to the more electronegative oxygen atom. Now the hydrogen, since it has lost its electron, it will gain a positive charge and will get a proton, H positive ion, whereas the OH negative ion, or the hydroxyl group, it will remain attached to the aluminum. It will keep hanging to the aluminum. Now the charge of OH negative is minus, right? It's -1. The overall now, and the charge of H positive is +1. What's the charge of this entire molecule? Initially it was +3, right? This positive charge won't allow another positive charge to stay inside, because positive charges would repel one another, and that's a bigger charge. So of course it will try to repel the H positive ions out of this complex ion, and so this H positive ion would actually be released into the solution. And I guess most of you might have assumed why the pH was 3, because the pH now, this H positive ion which has been released due to the polarization of the water molecule will cause the pH to decrease, because these H positive ions, because what is pH? pH is the power of the hydrogen ion, the concentration of hydrogen. The greater the concentration, the lesser the pH. So H positive ions will increase due to the polarization caused by the aluminum over here, and hence the H positive ions would be released out and the pH would actually fall. The OH negative ion, on the other hand, what it will do is, it will, since it has a negative charge and the overall charge was 3 positive, this negative charge will get subtracted from that 3 positive, and now the overall charge would become a 2 positive in this species. Why will this become a 2 positive? Because you've added a negative ion in there. So now the charge will no longer stay as 3 positive, because one of the positive charges will get neutralized by the negative charge brought in by the OH negative, okay? Or you could think of it this way, that the 3 positive charges, one of those charges went out into the solution. But guys, this doesn't mean that only one water molecule was polarized. There would be thousands and thousands of water molecules that would be polarized continuously to produce thousands of H positive ions out, due to which the concentration of the entire solution will change to such an extent that the pH will fall drastically to 3, okay? So this entire discussion or explanation that I've explained over here is written in these 2 lines over here, in these 2 equations. And by the way, if you are asked on the exams to write down the equation or explain in terms of equations for why the pH is equal to 3, so these are the ones which you are expected to write down on your exams, and these are the ones which are written in the marking scheme as well. Now let's go over them one by one. AlCl3 will combine with 6 water molecules, forming this complex ion. This is how the complex ion is written, okay? This is how the complex ion is written. It's 6 water molecules attached with 1 aluminum, and the overall thing has a 3 positive charge, because water is neutral and aluminum has a charge of +3, along with the chloride ion that is removed out. The 3 chlorides are kicked out into the solution. Now this ion which is formed, it was originally in that form. This is what you are supposed to show to the examiner, okay? Now after this is formed, you draw out another arrow and you make 5 water molecules and 1 OH molecule. Why 5? Because the 6th water molecule, it got broken down into OH negative and H positive. The OH negative stayed inside because it's negative, and this is a positive aluminum ion. It will keep the negative ion with itself, whereas it would release the positive ion. It would release the H positive ion. Okay, so now in the external solution, we've got a mixture of H positive and Cl negative. H positive and Cl negative actually refers to hydrochloric acid. So the outside solution would actually get a slight concentration of hydrochloric acid in there. Or I should say that concentration of acid will start rising in the solution, due to which the pH will fall to 3. The same concept applies to magnesium chloride as well in reality. not in our syllabus by the way, but in reality magnesium also has a somewhat polarizing power, meaning higher than sodium of course. So it also causes one of the water molecules to polarize, okay, and as soon as it polarizes it releases the H positive ions, and the H positive ions cause the pH to decrease slightly, okay. But this explanation for magnesium is not relevant to you guys if you're studying from Cambridge, but it is definitely relevant for aluminum in our syllabus in Cambridge as well, okay. So now to sum this entire discussion up, for chlorides, sodium chloride and magnesium chloride and AlCl3, these three chlorides are actually collectively asked on the past papers quite commonly. When sodium chloride and magnesium chloride are asked, you would say they dissolve in water, they do not react, and if the equations are asked, this is how you're going to write them down, aqueous. But if AlCl3, if the reaction of AlCl3 is asked, you would say AlCl3 hydrolyzes in water, or it reacts with water and AlCl3 produces that, and the equation that you are supposed to write, these are the two equations that you are supposed to write, okay. You always have to write down the two equations in order to justify the low pH of 3, okay. AlCl3 combining with 6 water molecules forming that ion, and this ion, actually the Al polarizes the water molecule into OH and H positive ions, and these H positive ions cause the pH to decrease, because the greater the H positive ions, the lesser the pH. And that's it for this video. Thank you.